Hi there, I'm Nidhi Johnny. I'm a wireless LAN technical marketing engineer for HP Aruba Networking, and in this video, we will look into the automated client optimization technology called ClientMatch. We will focus on ClientMatch for access points running AOS 10. In this video, we will cover an overview of ClientMatch in AOS 10 and how it differs from AOS 8. We will take a detailed look at why it is needed in modern WLAN environments. Then we will look at the functionalities of ClientMatch, its detailed workflow, and configurations available in HP Aruba Networking Central for AOS 10 APs. So what is HP Aruba Networking's ClientMatch? ClientMatch is patented Wi-Fi client optimization technology with Wi-Fi 6 awareness that enhances user Wi-Fi experience. While ARM and AirMatch focus more on RF management at the AP level, ClientMatch focuses on the client level. ClientMatch identifies the clients that do not get the required level of service from the associated AP radio and intelligently steers such clients to an AP radio that can provide better service. For access points running AOS 10 and managed by HP Aruba Networking Central, ClientMatch is one of the cloud services in Central. The main difference between AOS 8 and AOS 10 regarding ClientMatch is that the orchestration of this feature is now handled by Central in the cloud instead of on a mobility conductor. ClientMatch continuously gathers RF performance metrics from mobile devices and uses this information to intelligently improve the client's experience. ClientMatch dynamically optimizes Wi-Fi client performance even while users roam and RF conditions change. Now let's look at why a feature like ClientMatch is required in modern WLAN environments. ClientMatch is needed to address several issues that can arise in modern Wi-Fi environments, particularly in dense networks or large campuses with multiple access points. To understand why ClientMatch is needed, let's look at how client behavior affects WLAN performance and what factors affect it. Some of the factors affecting WLAN performance are client decisions, poor roaming algorithms on clients, sticky clients, and vast diversity of clients. Let's look at these in detail. So Wi-Fi devices decide which radio it connects to. They typically control connectivity decisions such as which API to associate to, data rates, and roaming. They lack system-level view and hence they might connect to a congested 2.4 GHz radio even when a cleaner 5 GHz band is available. Modern WLAN environments are dense environments which require adequate load balancing of clients to ensure optimal performance. Next is poor roaming algorithms. Again, roaming decision is client-specific. Clients decide when to roam and to which access point to roam to. Each device will have its own proprietary roaming algorithms that decide the signal threshold when roaming will be triggered on the devices and what APs they decide to associate to. Often, we will see some clients with higher roaming sensitivity while some others still connected to AP with less signal. Client roaming algorithms also need to take into account other factors when deciding to roam. Some of the common issues due to poor roaming algorithms are slow or premature roaming, causing connectivity issues and inefficient handovers. Next is sticky clients. Once attached to an AP, clients tend to stay attached, even when users roam away from the AP. This sticky client issue will degrade the performance for every connected client, not only because signals tend to weaken as users move away from an AP, but speeds downgrade to a slower rate. Next is the vast diversity of clients. With the growing number and type of mobile and IoT clients accessing bandwidth-intensive applications, airtime is becoming increasingly valuable. The sheer number and diversity of clients impacts performance because slow clients impede all other clients. Now that we know some of the common issues affecting WLAN performance, let's look at the different functions of the ClientMatch service. Different functions of ClientMatch service are spectrum load balancing stationary clients, band steering or band balancing client devices, eliminating sticky clients, and matching client capabilities with AP capabilities. Let's look at these in detail. Now, before we look at the functions in detail, we need to understand the two types of moves that ClientMatch uses to move clients to a desired radio. They are deauth moves and BSS transition management moves. In deauth move, the AP sends a deauth action frame to the connected station. Then, It does not let this station associate anywhere but to the desired radio for a duration of time after this frame is sent. In 802.11b BSS transition management move, the AP sends a BTM action frame to the station, suggesting that they should instead be moving to that BSS ID. These frames are not mandatorily obeyed by the station and are sometimes ignored or rejected. If that happens 5 times or more, ClientMatch will trigger a deauth move instead. It is important to note that ClientMatch uses the deauth steer method as sparingly as possible. It is only used to steer sticky clients, specifically clients that do not support 802.11b and those that support it but are not responding to the BTM requests. Now that we know how ClientMatch moves clients to decide AP or radio, let's look at its functions in detail. Spectrum load balancing balances clients across different channels to balance the total client load. This is a feature that is more frequently used in high-density environments such as auditoriums. Spectrum load balancing feature helps optimize network resources by balancing clients across different channels, which in turn leads to distribution of clients across different radios. It aims to balance out the number of clients on a per channel basis to ensure not all clients are connected on the same channel but across the spectrum. This also ensures that the load is split across the network. Next is automatic band steering or band balancing. Depending on the client specification, the client decides on which band it would join. Dual band clients associate with the 2.4 GHz or 5 GHz radio of an AP. In band steer, ClientMatch moves dual band clients from 2.4 GHz radio to the 5 GHz radio of the same AP. For those clients that support 6 GHz, ClientMatch will attempt to move them to the 6 GHz radio. Next function is to eliminate sticky clients. This feature comes into play in a scenario such as when a client associates to an AP while within the prime coverage area and then moves away to the edge of the coverage of the radio, but the station does not roam voluntarily. ClientMatch is then aware that there is an AP that would be better option for the station and is able to tell the client to move to the better candidate. And finally, ClientMatch ensures that client capabilities are taken advantage of by ensuring they are associated with a radio with similar capabilities. The goal of this is to move stations that are MU-MIMO capable so that they are on the same radios so that the AP can leverage the MU-MIMO function as two stations of appropriate types are necessary for an AP to be able to do MU-MIMO. Some stations refuse to cooperate with ClientMatch and such will be put into an unsteerable stations list. They will be in this list for 24 hours if the client device ignores more than 5 consecutive 802.11v moves. And they will be in this list for 48 hours if there has been 3 unsuccessful deauth steer attempts. This list of unsteerable clients can be viewed using the REST API. Client devices known to not support being steered by ClientMatch can be added permanently to the unsteerable list by using the REST API. Now let's look at the workflow of ClientMatch service. This is a high-level workflow of the ClientMatch service when steering a client device. So access points send telemetry to the ClientMatch service in Central. This is not only for the associated clients, but for all the clients that it can hear. The AP telemetry includes information like client info, which includes the client capabilities, client RSSI, which is the received signal strength, client events like roaming success or roaming failed, which the source AP sends to the cloud, BTM response event, which is the response from client for the BTM request messages. These are some of the AP telemetry that is sent over to the ClientMatch service in Central. Now ClientMatch stores all this information to a database. Next, the ClientMatch service does its network data lookup. AP, radio, and virtual AP data are read from the database during a steer attempt. That is, when ClientMatch finds that a station could be steered to a better radio. ClientMatch load balancer also needs to look up which clients are associated to a particular radio. Once ClientMatch has the required information, it sends the steer action command to the AP. The AP attempts 802.11b BTM if the client supports, else will fall back to deauth steer. Finally, we have the client steered to the target AP. So ClientMatch is enabled by default and does not have configuration options when deployed using AOS 10. However, There are some configuration changes that we can make using central REST APIs. Let's check that here. So go to Organization, select Platform Integration tab, click on REST API, click this link under All Published APIs, and it brings us to the Central Network Management APIs page. Under Category, select ClientMatch, and now we can see all the available REST APIs for ClientMatch. Go ahead and enter your access token here for authentication. Now, if you want to check the current status of ClientMatch for your central account, then we can use this API. Enter the tenant ID here for your central account, then click on Try. Here you can see that ClientMatch is enabled. Now, for some reason, if you need to disable ClientMatch, you can do it using this API. Give the tenant ID and in the body specify the desired state of ClientMatch. Now you can see that I have disabled ClientMatch. So by using this API, you can enable or disable ClientMatch service. Now we can also check the status of the load balancer service of ClientMatch using this API. You can see that it's enabled. So you have the option to disable just the load balancer service of ClientMatch using this API. This will only disable the load balancer service and not any other functionality of ClientMatch. And there you have it. I have disabled the load balancer functionality of ClientMatch service. Now we also have the option to disable the band steer to 6 GHz option using this API. You can first check the status using this API and then make necessary changes using this API. There, I have disabled the band steer to 6 GHz option. Now we can see the list of all the clients that ClientMatch tried to move to a desired radio but failed. These are categorized as unsteerable clients. We can see the list of all unsteerable clients using this API. So you can see here I have one client here. You can also check the status for specific clients using their MAC address. Specify the client MAC address here. Now you can also add clients known to not support ClientMatch to this list using this API. Specify the client MAC address and the type of steer. Sticky steer and band steer are the available options. We can specify the duration in minutes. You can also use this API to delete any client that has been marked in the unsteerable state. So these were the REST APIs that you can use to manage ClientMatch in HP Aruba Networking Central for AOS 10 APs. For more information on ClientMatch service in AOS 10, you can refer our TME docs portal at arubanetworks.com/techdocs/AOS or the central product documentation page. And that's it for this video. Hope this video was helpful. Thank you for watching.